It's now time for our first and only example of the day, and this is math story time. So, take a moment, just watch the screen. According to legend, actually, let's draw us a little book first. And yes, there will be interactive drawings with this math story time. Alright, so according to legend, one of Napoleon's soldiers was able to estimate the width of a river using triangles. We're going to have a little soldier, and this soldier has a hat with a brim. The man was wearing a hat with a brim. He looked to the other side of the river, and he continued to tilt his head down until his brim was in line with the opposite bank. So he tilted till all he could see was the very edge of that opposite bank. He knew that the brim was in direct line with it. Well, what he then did was the man turned on the spot. He kept his his head in the same position. But he looked off to his side. And he noted the spot on the ground that he could see in line with the brim of his hat. So this point was very important. The man then measured the distance from him to this second point. So he measured this distance. And realized that it was the same as the distance that was across the river. Was the man right? Why or why not? Well, what we see is that this man has constructed a right triangle with his body and his line of sight and the ground. When he was looking across the river, the man had a certain height. When he looked to the side of the river, he still had that same height. He then was looking down at a particular angle. When the man turned, he was still looking down at the same angle. So we can see that these two triangles are congruent to one another by angle, side, angle. Because we have the top angle, the side, and then the right angle. Which means that their corresponding parts, in particular, the base of these triangles, those distances are congruent. So CB is congruent to ZY because they are corresponding parts of congruent triangles. And so this is, in fact, how you can estimate the distance across a river.